Well, thank you for sticking around. I'm going to be the last talk here, and so I'll try to go quickly. This is about OFA Sunfish and some of the integrations we're going to be trying to have with SNIA Swordfish. So if you're not familiar, Sunfish is an open source standard reference framework for dynamic fabric and device reconfiguration. It's geared towards composable disaggregated infrastructure for both enterprise and HPC applications. And so it interfaces with Redfish, Swordfish, CXL, and any APIs that people want to contribute for device and fabric management together. So it's part of the OpenFabrics Alliance. So we kind of have a disconnect right now, especially as we move towards AI applications. Totally proprietary fabric and storage managers have dashboards that your marketing department absolutely loves, but customers don't necessarily look at. They don't work with other vendors' products, so there's minimal interoperability. They can become a maintenance nightmare, especially the ones we've seen that are HPC specific, but they do keep developers employed, so that's kind of that's the good thing. However, as a customer, as coming from Livermore Computing, and then also we have been talking this over with the other national labs, multi-tenant security is becoming really critical for us, especially for AI and agentic workflows, and a lack of a standardized management interface is actually beginning to limit customer adoption of new technology. So I imagine that we in HPC with our tightly coupled workflows are probably not too far away from your enterprise customers who are also going to be trying to do trying to do tightly coupled AI workflows as well. So in order to make a lot of our stuff work, not only modeling and simulation workloads, and this is modeling things like high energy physics, protein folding, cancer research, and things of that nature. We want to begin using AI to reduce the time to scientific insight for the scientists who are doing simulations on our systems. We need to be extremely flexible, and so we're often a vanguard customer in adopting new technologies such as persistent memory, fabric attached memory, near node local storage, near node local flash. We have custom AI accelerators in our center from Cerebras and Samba Nova. We're looking into others. And we want to start looking at secure network and compute enclaves and storage enclaves as well. So sort of the question is, how does Sunfish help? Well, Sunfish provides an open source reference framework for a multi-device management solution. So if you think about it from a vendor standpoint, your hardware team can provide a reasonable, sane Redfish or Swordfish API, and then your software team can then implement an agent-based management solution. And as long as you have a reasonably open stack throughout, from all the way from the hardware agents all the way up to the front end that the customer could see, then different customers can plug in at different layers, right? So you might have enterprise customers who really do want a point-and-click dashboard, but then you also can have HPC customers like us that are going to want to automate management with resource schedulers, managers, et cetera. The other thing that's kind of exciting about this is getting device telemetry. So for a long time, we've been talking about we work with batch workflows. So if a user runs a job, then we want that user to be able to get feedback on how did that job hit the hardware, what resources did they use, how did those resources work, et cetera. So anyway, Sunfish agents can hide hardware specifics by not really creating, but leveraging Redfish models of resources. This is sort of the overall graph of the basic concept of how it works. Sunfish Services manages all the Redfish models for all the hardware agents, and then the Sunfish clients, which in this case could be your management dashboard, or it could be a resource manager like Flux, it could be an orchestrator like Kubernetes, then can see the abstracted fabric-attached resource objects. So Sunfish helps provide this sort of translation layer that provides a northbound interface to your resource managers and workflow orchestrators. So this is the kind of more eye chart, complicated diagram, but for example, you could have a variety of different fabric managers. So this is actually kind of like what your customer's view could be. You have a variety of different fabric managers that all plug into the hardware, okay? And then as a customer, what I want to be able to do is I want to be able to provision on the fabric all the way through to the storage. I want to be able to provision some type of enclave for my customer. I need to do this for a few million processes running over tens of thousands of physical nodes, a node being analogous to a blade. And we want to do this in less than a minute. And so the amount of, the thing to consider as a solutions provider is that the end-to-end solution is probably out of scope for what you're trying to do. So this is where openness is so critical. So anyway, the core components of Sunfish are, we have both a library reference, which is available open and online, and we have a Sunfish agent and server reference, which are combined into the Sunfish server, and it's just providing a Flask-based RESTful agent and server implementation. We offer a reference implementation of a Sunfish compatible hardware agent, what it would look like, how it would have to respond to queries, pushes, and gets. The whole point is that it's very, very modular and it's very, very scalable. So if need be, custom agents can be created for your application. You can dynamically import plugins directly into the core library, so you can be extremely customizable even beyond Redfish or Swordfish if you want. But the best option is really obviously to implement Redfish or Swordfish and stay away from extremely, ultra customized solutions. So one of the questions that was brought up earlier was, so you've got two agents, they both see the same storage device or the same port on a switch or any kind of hardware thing, okay? And so now we have this problem, which is that since both of them see the same device from different views, they may actually conflict, right? So the question, one of the open problems that Sunfish models a solution to is how do you handle this multi-agent boundary component duplicate object problem? And so Sunfish actually handles this through aggregating all of the resources from the various hardware managers, and then it uses some code inside the server reference that goes ahead and actually systematically deduplicates the various matched objects that are in the overall resource tree, and so then it creates a coherent resource graph. And so this is one of the features that, really, to my knowledge anyways, missing from a lot of the orchestrator frameworks, and definitely was one of the value adds for HPC resource manager frameworks as well. And so this is an example of what the merged model of two fabric appliances look like. So, you have some kind of CXL switch here and this is an enclosure for a fabric attached memory device. And then you have like an NVMe enclosure or SSD enclosure here. And both of them see the same CXL fabric. And so without this deduplication, you would have a really difficult time doing provisioning accurately because you would have multiple representations of the same endpoints and ports on the CXL fabric. And so the deduplication, that's kind of the whole point of doing this. So the question could be, so why use Sunfish for storage? And again, it's the disaggregated storage and persistent memory, I think, is going to become really, really important, especially for AI workloads. There's a demand for complex in-storage compute processes, such as data cleaning. And these are best managed by dedicated hardware. I'll get into a little bit more of that in a bit. And then speed and throughput requirements are outpacing traditional storage array capabilities, at least for us. So what we kind of need is composable storage infrastructure. So in the world's fastest supercomputer, El Capitan at Lawrence Livermore Lab, we have Hewlett-Packard Enterprise Rabbits. These are dedicated storage compute nodes that sit in the racks of the supercomputer on the back side of the rack, and the front side has all of the compute. They're water-cooled, they're hooked up directly with PCI Express switches to the various nodes in the rack through a backplane, and then they're also hooked up through HPE's Slingshot high-speed interconnect to the rest of the overall system. These Rabbit nodes, not only they contain, commodity processors and then a ton of NVMe storage, and not only are they actually able to provide Lustre parallel file system access to the applications, but they can also perform complex compute and data cleaning activities. And so one of the reasons that we are deploying Rabbits is, first of all, our modeling and simulation workloads at the scale of El Capitan and the speed that it has in the MI300A compute accelerator units is actually too much to write to our Lustre parallel file system. It would actually overwhelm the file system over the fabric due to fan-in behavior. So that's why we actually have to use these Rabbit nodes so that we can just write to the nodes in the rack as a scratch space. And so one of the workloads that we'll do that's tightly coupled, for example, is we'll have a modeling and simulation workload that'll run on the compute accelerators. And then the temporary results will be written to the Rabbit nodes. Then we'll switch into an AI mode or a machine learning mode, where now that we have a bunch of simulations of, say, some event occurring, or we have simulations of different proteins, we'll ask that AI, what is the best candidate that you saw from all of the results that we've presented you? And then the AI can then do its reasoning and then determine the remaining, what should be done in the next step of simulation. And so this back and forth switching is done with Rabbits. And we think that this is going to be probably very common, not only throughout industry, but also, not only throughout HPC, but also industry customers. But of course, we have a lot of needs that come from AI, and that we're still working to try to make sure these workloads are secure. And so multi-tenancy is going to be an issue moving forward. We are looking into containers, but we also need to figure out how to do VXLAN style provisioning to make sure that we have secure access all the way through to storage. We also want to create secure storage enclaves, so we need to be able to provision all of this. And so this is another thing that we need something like Sunfish to do. And here's kind of a diagram that comes from our latest request for information from Livermore. This was participated in by pretty much all of the major national labs, where this is kind of an overall description of what I've been talking about. These are the types of workloads we're looking at. And so when we do, when we create this new future center, we need interoperability basically to the max. We don't necessarily even know if we are going to be doing our AI and machine learning models in the supercomputer, or if we're even going to be using appliances like the ones we have from Cerebras and Samba Nova, that we're going to use wafer scale chips and technologies of that nature to do our AI workloads that go parallel with our compute workloads. So in the future, we're going to need a lot more complexity in the control plane, and we're going to need a lot more interoperability between vendors. To this end, you might have heard of the Slurm workload manager, which is popular in the HPC community. But we actually at Livermore have our own workload manager because we needed a hierarchical model, and we also needed to handle multi-constraint scheduling, particularly for HPE's Rabbit nodes. And so we are working on a standard API within the Flux project for scheduling heterogeneous storage and AI accelerator resources. We're currently at the point interacting with the Sunfish project where we have prologue and epilogue scripts for setting up and tearing down resources. But the cool thing about Flux is that it does have a little bit of overlap with Sunfish, and that Flux can reason about resources that are already provisioned and dividing up resources, et cetera. So it is theoretically possible to run a Flux broker on a Rabbit node, and then the Flux broker will provision out the storage on the Rabbit node as needed. And so, yeah, I think that when it comes to overall actually selling and solutions and getting these solutions out into data centers, sometimes I think that customers don't know what they want until you show it to them. That's a quote from Steve Jobs there. But a lot of times there's a sense that people don't necessarily buy the hardware until it's shown what can be done with it. And so I think that adopting open management standards is just essential to providing these solutions to customers and pushing the state of the art forward. And so it helps provide that maximum interoperability, minimum delivery time, and minimum maintenance cost. So what you can do is check out OFA Sunfish, choose and copy it, steal it. We are completely open. You don't have to join OFA in order to participate in Sunfish. You can join the meetings. And then also, choose an open source management API and implement it in earnest. Represent hardware features accurately, represent it consistently, and avoid breaking changes. And this is, I think, the foundational way to really move forward and build these data centers of the future. And that's it. Any questions? Yep.
How many lines of code of this actual project, not data behind it or mock-ups or anything, has been written?
So I would, yeah, it's in the order of just thousands, because it's really at this stage, I think, more of a proof of concept of how you could do something like this with Redfish and Swordfish and CXL. It's mostly Python. It's a Flask-based application. And so we've taken a few of the mock-ups and we've solved a few of these different multi-agent tree problems and things of that nature. So I think it's kind of a good jumping off point as it starts right now, but it's not anywhere near like a production Fabric manager.
Have you started any of the resource reconciliation work, same resource found by two?
Yes.
Okay.
Yeah, we have a demo of that. Yeah, we have a demo of that going. And that was like one of the main points, to also show our Flux team that saying, do you really want to do this? So, yeah. Okay, well, thank you very much. Thanks for staying.